Hi, good morning. This class we are going to talk something related with problems in loss of motion. Problems in loss of motion. Three basic Newton's laws we know. Every body continues in its state of rest or of uniform motion unless it is compelled by an external force. So this is first law. Rate of change of momentum is directly proportional to the applied force. Momentum is product of mass and velocity. So rate of change of momentum is equal to the force. That is called second law. To every action, there is an equal and opposite reaction. It's the third law. Action is equal to minus reaction. Law of conservation of momentum also we should know. Total momentum before collision is equal to total momentum after collision. That is, in the absence of external force, the momentum of the body is conserved. That is called conservation of momentum. Then impulse. Impulse is product of force and time. F into T. Or change in momentum also we can call it as impulse. Then frictional force. Whenever your body is moving on a horizontal surface or an inclined plane, it has to overcome the frictional force. The body is not moving means the friction is said to be static friction. So we should know something, a relation between force and normal reaction with the coefficient of friction, coefficient of static friction. When the body just started moving, static friction changes into kinetic friction or dynamic friction. Mu S is the coefficient of static friction. Here it is mu K, coefficient of kinetic friction. So all these basics we know. Keeping that in mind, we'll go to the problems. Okay. A car of mass 1000 kilogram is moving with a velocity of 10 meter per second and it is acted upon by a forward force of 1000 Newton due to the engine and retarding force of 500 Newton due to friction. What will be the velocity after 10 seconds? Forward force is given, retarding force due to friction is given. So we have to calculate net force. Net force is equal to forward force minus retarding force. What is the forward force value they have given? 1000 Newton. And retarding force is 500 Newton. So 500 will be the net force, NF. The question is, what is the velocity after 10 seconds? So once you know the force, you have to calculate the acceleration. A is equal to force by mass. Net force, Fn also you can write, no problem. Fn. So that is 500 by mass is 1000 kilogram. So we can write 1 by 2, 0.5 meter per second square. 0.5 meter per second square is acceleration. Velocity and acceleration relation P is equal to U plus AT. This is a question. Initial velocity 10 meter per second. Acceleration is 1 by 2 or 0.5, whatever it is you can write. Time is 10 seconds. So pi 15 meter per second is the velocity. Definitely equations of motion we know, we should know. For solving any problem related with laws of motion, the basic thing is equations of motion. velocity, acceleration, displacement by time, velocity by time, and all basic concepts. Second problem, a bullet of mass 0.04 kilogram moving with a speed of 90 meter per second enters a heavy wooden block and is stopped after a distance of 60 centimeter. What is the average resisting force exerted by the block on the bullet? You have to calculate the average resisting force. That means here we have to calculate the retarding force. Previous problem, retarding force is given. Here retarding force we have to calculate. Okay, for that force means acceleration should be known. Retarding forces. So retardation we have to calculate. So calculate acceleration. Negative of acceleration only we call it as retardation. So calculate negative of acceleration. Basic formula v square is equal to u square plus 2as. To stop the body, so final velocity is 0. Initial velocity 90 meter per second. So 90 square plus 2a. What is the displacement given? 0.6 meters. So 1.2a is equal to 90 square. A is equal to 8100 by 1.2. We have to calculate this. Of course, minus sign will come. Minus 6750 meters per second. Second square acceleration. Question is retardation. Therefore, retardation. Negative of acceleration. That is 6750 meter per second square. Retarding force. MA. A is retardation. A dash. So mass given here is 0.04 into retardation is 6750. 6750 multiply, you will get 270 Newton. 270 Newton. So directly acceleration we cannot calculate here. Even though this formula is same, calculate the acceleration, then negative acceleration will give you retardation. Substitute in retarding force. What is the force necessary means MA. So answer will become minus. Okay. Right. This is second one. Third problem. A force of 72 dyne is inclined to the horizontal at an angle of 60 degree. The acceleration of, find the acceleration in a mass of 9 gram which moves in the horizontal direction. Find the acceleration in a mass of 9 gram. 72 dyne force is given. Acceleration is force by mass. Horizontal component of force is F cos theta. Resolution of vector theta towards x-axis, if you put horizontal component is F cos theta, vertical component is F sin theta. So F cos theta, what is the value? 72 dyne. This is cos 60 divided by mass is 9 gram. This is in dyne. This is in gram. We can definitely convert both in terms of SI unit and then write the answer in SI unit. Since both are in CGS unit, we can write as it is. Answer also you get in CGS unit. 72 cos 60 is half by 9, 8. Acceleration is 4 centimeter per second square. Answer also in CGS unit. Okay. Fourth problem. A force acts for 10 seconds on a body of mass 10 kilogram, after which the force ceases and the body describes 50 meter in the next 5 seconds. Find the magnitude of the force. Again, to calculate force, we should know the acceleration. Then MA directly we can use. The force ceases. Before the force ceases, the body covers a distance of 50 meters. Time given is 5 seconds. So velocity is equal to distance by time. 50 meters by 5, 10 meter per second. So you have to calculate the acceleration. What is the acceleration? Basic formula. V is equal to U plus AT. Initial velocity is not given. The force ceases 0 plus this is 10. A into the time taken is 10 seconds. Therefore, A is equal to 1 meter per second square. Force F is equal to MA. What is the mass given in the problem? 10 kilogram. 10 into 1. So answer is 10 Newton. So that is the force asked. We have calculated as 10 Newton. Fifth problem. A truck starts from rest and rolls down a hill with a constant acceleration. It travels a distance of 400 meters in 20 seconds. Calculate the acceleration and the force acting on it if its mass is 7 metric ton. First, we have to calculate the acceleration. Then we have to calculate the force. Problem number 5. Sir, here start from rest. Displacement is given. That is, distance is given. So S is equal to ut plus half at square formula only we have to use. Because distance related with acceleration, this is the only formula. Another formula V square is equal to U square plus 2AS. But there is no time involved in that equation. Here velocity is also not given. So we have to use this one. 400 meters start from rest. So initial velocity is 0. Half acceleration is A, time t square. What is the value? 20 seconds. 20 square. So 400 is equal to A by 2 into 400. Cancel. A is equal to 2 meter per second square. Force F is equal to MA. What is the mass given? 7 metric ton. 1 ton means 1000 kilogram. 7 means 7000 kilogram into 2. 14,000 Newton is the answer. 14,000 Newton. Ton we have to convert in terms of kilogram. 1 ton means 1000 kilogram. Okay. So this is the basic thing. Next. A force of 5 Newton gives a mass m1, an acceleration of 8 meter per second square, and a mass m2, an acceleration of 24 meter per second square. What is the acceleration would it give if both the masses are tied together? Individual acceleration given, basic formula F is equal to ma, m1 a1, m1 is equal to F by a1, because same force for both the masses. So it is not F1, F2, it is F only. So what is F? 5 Newton, acceleration 8. So 5 by 8 kilogram. For second body, F by A2, 5 by, what is the mass given? What is the acceleration given? 24. So 5 by 24 kilogram. Therefore, total mass, if it tied together, then the total mass we have to calculate. Then only we can calculate the acceleration. Total mass will be 5 by 8 plus 5 by 24. 24 LCM, 3 times 15 plus 5. 20 by 24. That is 5 by 6. Force, acceleration A dash or A, when it is tied together, formula is same. F by, instead of M1 or M2, tied together means it is M1 plus M2. So I can write F is 5. This is 5 by 6 will go to numerator. So answer is 6 meters per second square. Acceleration is 6 meters per second square. Okay, next. Question number 7. In an X-ray machine, an electron is subjected to a force of 10 power minus 23 Newton. In how much time the electron cover a distance of 0.1 meter? Mass of the electron 10 power minus 30 kilogram. How much time? First we have to calculate the acceleration, then use the displacement acceleration formula. Acceleration is force by mass. What is the force given? 10 power minus 23 Newton. Electron mass is 10 power minus 30 to be taken. Actually, it is 9.1 into 10 power minus 31. That is 0.91 into 10 power minus 30. 0.91 only we are approximately taking as 1 according to the problem. So 10 power 7 meter per second square. Basic equation S is equal to ut plus half at square. Initial velocity is 0, half, acceleration is 10 power 7, time t square. Displacement is given in the problem, 0.1 meters. How much time? Question is t. So t square will be 0.2 by 10 power 7. 2 into 10 power minus 8. T square is this. This is root 2 into 10 power minus 4. 1.414 10 power minus 4 seconds. Or 0.14 milliseconds. Anything you can write. Eighth problem. A force of 15 Newton is inclined to the vertical at an angle of 30 degrees. Find the acceleration it produces in a body of mass 2 kilograms which moves in the horizontal direction. Component of force horizontal direction is Fh is F cos theta. 50 Newton force is inclined to the vertical at an angle of 30 degree. Horizontal means the vertical only angle 30 degree. So horizontal direction means it should be 90 minus theta. So remaining total is between vertical horizontal total is 90 ma. It is inclined angle of 30 degree. So remaining should be 60. So we have to subtract from 90. So F sin theta. Okay. Acceleration we have to calculate. So this is 50 sin 30. Sin 30 is half 25 Newton. Therefore, acceleration is force by mass. 25 by, what is the mass given? 2 kilogram. 2. So A will be 12.5 meter per second square. 12.5 meter per second square. Okay. Next, ninth problem. A ship of mass 3 into 10 power 7 kilogram. Initially, a truss can be pulled through a distance of 3 meters by means of a force 5 into 10 power 4 Newton. The water resistance is negligible. Find the speed attained by the ship. First acceleration we have to calculate. Acceleration is force by mass. What is the force? 5 into 10 power 4 Newton. Mass is 3 into 10 power 7 kilogram. Simplify 5 by 3 into 10 power minus 3 meter per second square. Question is, we have to calculate the velocity. V square is equal to U square plus 2AS. Starts from rest anywhere. The word starts from rest means initial velocity is 0. So 0 plus 2 into A is 5 by 3 into 10 power minus 3. Displacement is 3 meters. 10 into 10 power minus 3. That is 10 power minus 2. V square is 10 power minus 2 means V is 10 power minus 1. That is 0.1 meter per second. This is the velocity of the ship. 10th problem. A batsman hits back a ball straight in the direction of bowler without changing its initial speed of 12 meter per second. If the mass of the ball is 0.15 kilogram, determine the impulse imparted to the ball. Linear motion alone we have to accept here. Because in a plane means you have to consider the theta, the angle subtended, that is not given in the problem. So initial mass, initial velocity, impulse imparted by the ball we have to calculate. So final velocity, impulse. Impulse is mass into change in velocity, change in momentum. Mass is constant, so change in velocity. Impulse J is equal to mv minus mu, m into v minus u. Mass is 0.15 kilogram. Velocity, initial speed 12 meter per second. The batsman hits back. Final velocity, that is also 12 meter per second minus 12. So 0.15 minus 24. That is impulse. Calculate minus 3.6 Newton second. Force into time also impulse. Change in momentum is also called impulse. Both are same. 11th problem. Figure shows estimated force time graph for a baseball struck by the bat. This is the figure given. Force versus time. Time along x-axis. Force in Newton along y-axis. Okay. What are the data given? 6,000, 12,000, 18,000. Newton. Expressed in Newton. Expressed in seconds. So here 1.5, 2.5, 1.5, 2.5. Two 2.5. This is in seconds. So this is 2.5. 0.5, 0.5, it is increasing. That is the diagram says. Okay, now what we have to calculate from the graph? That is a question. First one, determine impulse delivered. Impulse. Impulse is force into time. Generally, any graph you take, area of the graph will be product of x-axis and y-axis. Any graph. You are calculating the area of the graph means it is the product of x-axis and y-axis. X-axis and y-axis is force into time. Force into time, if you multiply, you will get impulse. So that is nothing but the area of the graph. It is almost equivalent to a triangle. So I can write half into base into height. Half into f into t. What is the force given? 18,000. Height is 18,000. Base is this point to this point, 2.5 minus 1. 1 by 2, 18,000. So it will become 9,000 into 1.5. So 13,500. 9, this is 3 by 2. 27,000 by 2. So 13,500, 1.35, 10 power 4 Newton second. Newton second is the unit of impulse. Second, calculate the force. Force is impulse by time. 1.35 into 10 power 4 by time taken 2.5 minus 1. What they are getting? 9,000 Newton. Next, what is the maximum force? Maximum force in the graph itself, it is known F max. 18,000 Newton. Straight away. From the graph, we can say maximum value is 18. Correct? So, this is a good question. Using the given graph, calculate impulse, force, and the maximum force. 12th problem. Calculate the impulse necessary to stop 1,500 kilogram car traveling at 90 km per hour. velocity 90 kilometer per hour, meter per second means multiply by 5 by 18, 5 times 25 meters per second is the velocity. What is the impulse? To stop the car, that is initial velocity u, final velocity is u. Generally velocity v we will write. In this case, initial velocity, final velocity. Stop. So final velocity is 0. Car is moving at the speed of, so initial velocity is 90 km per hour. Therefore, impulse is mass into change in velocity. What is mass? 1500 kilogram. V is 0 minus 25. 15 into 25 into 10 power 2. Multiply 37,500 minus. To stop the car means it should be opposite force only now. So definitely impulse should be negative. From the problem answer, you are getting negative value of impulse only. Okay. 13. A 75 kilogram man stands in a lift. What force does the floor exert on him when the elevator starts moving upwards with an acceleration of 2 meter per second square? When the lift is moving up, lift moving upwards. Definitely the value of G is negative. R is called normal reaction and the force is F is equal to ma. Normal reaction and the weight of the body, these two resultant. Normal reaction R is greater. Mg is smaller. So R minus Mg. Or G to be taken as negative when the body is moving up. Apparent weight or normal reaction force. So I can write R is equal to mg plus ma, m into g plus a. What are the data is given? 75 kilogram, G is 9.8, given as 10 in the problem. Question itself they are given 10. Acceleration is 2 meter per second square. So 12 into 75. 900 Newton. Reactant force, normal reactant force or apparent weight, anything can take. Or 14. The strings of a parachute can bear a maximum tension of 72 kilogram weights. By what minimum acceleration can a person of 90 kilogram descend by means of this parachute? 90 kilogram person is moving in parachute. Tension executed by the string is 72 kilogram weight. You have to calculate minimum acceleration. Parachute, the person is coming down. So the equation says R is equal to M into G minus A. Mg is positive here because body is moving down. That is F or tension, whatever it is. So T is equal to M into G minus. Normal reaction changed into apparent weight. Here normal reaction is changed into tension because it is string connected. So the force is nothing but tension here. Simple. What are the values? M into G. Maximum tension 72 kilogram weight. 72 into 9.8. Mass is 90 kilogram. 9.8 minus A. 9.8 minus A is equal to 72 into 9.8 by 90. Rearrange and calculate A. You will get 2.45 meter per second square. Acceleration of the body is 2.5 meter per second square. 15th problem. A 30 kilogram shell is flying at 48 meter per second. When it explodes, its one part of 18 kilograms stops, while the remaining part flies on. Find the velocity of the latter. Total mass is divided into two equal masses. So it is conservation of momentum. Total mass into total velocity is equal to first part mass, first part velocity, second part mass, second part velocity. Here, first part stops. So V1 is equal to 0. Question is given. Calculate V2. So V2 is equal to mu by m2. What is the mass here? 30 kilogram. Moves with the velocity of 48. Divided by second one mass is 12. So for 120 meter per second. First one mass is given, sir. Let it be, but it stops question. That means velocity of the first part is 0 after explosion. Okay. 16. A man weighing 60 kilogram runs along the rails with a velocity of 18 kilometer per hour and jumps into a car of mass 1 quintal, standing on the rails. Calculate the velocity with which the car will start traveling along the rails. Beautiful question. Man weighing 60 kilogram runs along the rail. He is running 18 kilometer per hour. That is the velocity of the man who is running. He is jumping into a car of mass 1 quintal. 1 quintal means it is 100 kilogram. 1000 means 1 ton. This is quintal. 100 kilogram. Car means it is not fully equipped car. Rails, it is moving. Rail, it is moving. So he is jumping into the car. Car is rested the rails. Calculate the velocity with which the car will start traveling along the rails. After he jumps into the car, what is the velocity of the car which is moving on the rail? Why they are using a rail car in a rail and also train only will move now. This is to check the points whether the connecting between the two rails, two different pairs of rails is correct, and a wooden plank in between the track and the stones, whether it is given correctly. The path is so clear to run. To check all these things daily, this most of the routes they will travel in a car which is completely open. Main body alone will be there. Simply it will move on the rails. just to check the passage. Okay. Conservate now momentum here also. M1 plus M2 into V is equal to M1 U1 plus M2 U2. What is the velocity after the person is jumping into the car? So 60 kilogram. Yes, man weighing 60 kilogram, 100 kilogram car into velocity V we have to calculate. This is 60 into U1. What is the velocity? 18 kilometer per hour. 18 into 5 by 18 plus M2. What is M2 given? 1 quintal, 100 grams, 100 kilogram is standing on the rails. So U2 is equal to 0. So 160 V is equal to 18 into 5 by 18. Cancel. 300 plus 0. So V is equal to 300 by 160, 30 by 16, 15 by 8. 15 by 8 is 1.88 meter per second. Velocity of the car moving in the rail. 17. Fuel is consumed at the rate of 100 kilogram per second in a rocket. The exhaust gases are ejected at the speed of 4.5 into 10 power 4 meter per second. What is the thrust experienced by the rocket? Fuel consumed at the rate of 100 kilogram per second. 100 kilogram per second means mass by time they have given. dm by dt is given. What is the value? 100 kilogram per second. Okay. Initial velocity 4.5 into 10 power 4 meter per second. Thrust we have to calculate. Thrust is nothing but force. M into dV by dt. Here V is 4.5 into 10 power 4. It is dm by dt. 4.5 into 10 power 4 into 100. 4.5 into 10 power 6 Newton. This is the force or thrust experience. Okay. A rocket is going upwards with an accelerated motion. A man sitting in it feels his weight increased by 5 times of his own weight. The mass of the rocket, including that of man, is 1 into 10 power 4 kilogram. How much force is being applied by the rocket engine? For that, we have to calculate the acceleration. It is moving upwards. Moving upwards means, of course, we need not worry about the minus and or plus sign. The question is, the person's weight, the person feels his weight increases by 5 times. So no other data given. So we have to write 5g. A is equal to g only here, but 5 times the acceleration. So it is 5g. G given as 10. So it should be 10 meter per second square. force F is equal to ma. What is m? 1 into 10 power 4 into a is 10. 10 power 5 Newton. G is 10, so it should be 50. 5 into 10 power 5. Okay, 19th one. A force of 49 Newton is just sufficient to pull a block of wood weighing 10 kilogram on a rough horizontal surface. Calculate the coefficient of friction and the angle of friction. F is equal to mu Rg or mu into R. Mu is equal to F by R. Normal reaction, and this is the force. Weighing 10 kilogram on a rough horizontal surface, coefficient of friction 49 Newton is just sufficient to pull. So 49. What is the mass given? 10 kilogram. G is 9.8. Unless otherwise given as 10, you have to take only 9.8 G value. So this is 98, 49 by 2, 49, 49 cancels. So 2 is the coefficient of friction. By 2. So by 2 means 0.5. Coefficient of friction is 0.5. This is first part. One more part is also asked. You have to calculate theta. Also, we know mu is equal to tan theta. Coefficient of static friction, mu s is equal to tan theta. So, theta is equal to tan inverse of mu. Tan inverse of corresponding mu is 0.5. Tan 30 is 1 by root 3. Tan 45 is 1. This is 0.5. 1 by root 3, 1 by 1.732. So it should be less than that 30-degree value. 26 degree. Natural tangents you have to take in logarithm. You need not muck up all these things. If right after this, if the value is not given in the question paper or the given data, or flux table is not distributed while doing the exam, means it is enough if you write up to this. Okay, next 20th problem. A block of mass 2 kilogram rests on a plane inclined at an angle of 30 degree with the horizontal. Coefficient of friction is 0.7. What will be the frictional force acting along the block? Frictional force basic formula just now we have seen. F is equal to mu R, mu into mg. Moving at an angle of 30 degree with the horizontal. R dash is R cos theta, mg cos theta. Generally, normal reaction means mg we can write. This is moving at an angle of 30 degrees of given. So it should be F is equal to 0.7 into mass 2 kilogram 9.8 into cos 30. 0.7 19.6 cos 30 is root 3 by 2. Simplify 11.9 Newton. This is a frictional force exerted by the body. Okay, so overall we have covered the basic problems in laws of motion topic, starting with 3 different laws. Then we have come across impulse concept. What is the force? What is the change in momentum? What is the time taken, like that? And finally, we have come to the friction formula. Coefficient of kinetic friction, coefficient of static friction. What is called coefficient of friction? So we have used almost all the formulas in laws of motion. Thank you. We'll continue.